Hello class, these are our notes for section 611 in Algebra 1. Today we are looking at graphing quadratics in factored form. So f of x equals, and we're going to write down the factored form of a quadratic. That's what it says here. So factored form means I need to have it in parentheses, but I have an a in front. Just like that a we multiply for our pattern when we're graphing. And then I'm going to write down x minus p times x minus q. So the x minus p, x minus q is the factored form. And then remember, like we said, a is that number that you would multiply your graphing pattern by. It is helpful for finding zeros of a function when we have this form and telling us the x-intercepts on the graphing. I guess it should just be graph, representing the function. So here's our little steps. We're going to start by solving with zero product property. We're putting our f of x or y equals 0 here, and those are our x-intercepts. We're going to graph our x-intercepts and then find our vertex. We're going to go through replace x, solve for y. We've got lots of steps here. I really think it's going to make more sense if we kind of just go through and work them out. So my first step is to let y equal 0 and solve for x-intercepts. So I'm going to take this function right here and I'm going to make it equal to 0. So 0 is equal to x plus 1 times x minus 3. Sorry, I got lots of noise in the background this morning, which means 0 is equal to x plus 1 or 0 is equal to x minus 3. So when I use zero product property, I get negative 1 is x or 3 is x. So let's go ahead and plot both of those. So remember, it's a negative 1, 0 and a 3, 0. So we do have our x and y coordinates there. And 3, 0. So halfway between those is going to be our vertex. We know that parabolas are, we know that they're symmetrical, and so we have to find the point halfway between those. So you can just look at it and eyeball it. Like I can tell halfway between those would be when my x equals positive 1. That's halfway in between. But we could also get that if we weren't really sure by adding those two numbers together and dividing by 2. So negative 1 plus 3 divide by 2. Negative 1 plus 3 is 2 divided by 2, so just 1. So that's my next step. So I know that my x needs to equal 1 at the vertex. Now I've got to find my y when x equals 1, which means I'm finding f of 1. So I'm going to go back up here to my function and I'm going to substitute 1. So f of 1 is going to equal 1 plus 1 times 1 minus 3. Well, 1 plus 1 is 2. 1 minus 3 is a negative 2. So that's going to be negative 4. Let's see. And so now I've got that point, right? My vertex is going to be 1, negative 4. So let's see, 1, 1, 2, 3, 4. And then my last step is really just drawing my parabola. So if this is my vertex, my parabola goes up, it goes through those x-intercepts. And then I'm just going to go ahead and graph it. So here's one side, here's the other side. I could fill in more points. I can look at this and kind of see like, oh, I should have a point here, I should have a point here. But really what we're trying to do is just quickly graph a parabola. So let's try our second one. For our second one, we want to do those same steps. So first we want to find our x-intercepts by letting our y equal 0. So I'm going to do that work up here. So 0 equals a negative x times an x plus 6. So 0 equals negative x, or 0 equals x plus 6. So that means we have 0 or negative 6. Those are our x-intercepts. So that was our first step. So our x-intercepts are 0, 0, and negative 6, 0. Let's go ahead and graph those. Then we want to find the x value at the vertex. So let's go ahead and do that. So I'm going to add those two together, 0 and negative 6, and divide them by 2. Or you could just look in the middle and say, hey, it's going to be negative 3. Okay, once we find the x value, we need to find the y value. So that means I want to plug -3 in for x and come out with y. So f of -3 equals negative of -3. That's just going to be positive times -3 plus 6. Let's see, that's going to be 3 times 3, which is 9. I'm kind of running out of space here. So then my vertex is going to be the -3 that I found by looking at halfway between, because again, parabolas are symmetrical, right? That's what a quadratic equation looks like. And my y value is 9. So my vertex is going to be -3, 9. So let's go ahead and plot that. -3, 9. And then I'm going to make my parabola. This one's upside down, but that makes sense because I have a negative here, right? It fits everything we know about parabolas. And there we are. So this is just a different way to graph. So if we have vertex form, we really like to just graph the vertex, do the graphing pattern. But if you've got a parabola in factored form, or if it's something that's easily factorable, this might make more sense. So we really want to think over the next few days about the best way to graph a quadratic. Last problem, we're going to find x and y intercepts of the function. So this is just kind of a continuation of what we were doing for that math problem that we just did. We want to be always able to find x-intercepts and y-intercepts, and just kind of think about the steps for that. So let's remember that if I am finding my x-intercepts, that those are where my y is equal to 0, right? They are points on the x-axis. That means we did not move up and down for y at all, and so our y is equal to 0. So we're going to let y equal to 0 and solve. If I am finding a y-intercept, that's a point on the y-axis, that means my x is equal to 0 because I did not move right or left at all when I was graphing. I only went up or down on the y-axis. So if we want to find an x-intercept, we always let y equal 0. If we want to find a y-intercept, we always let our x equal 0. And remember, sometimes we don't have any x-intercepts. We could have a graph that is above our x-axis and never crosses. So let's go ahead and get started. So I'm going to put a 0 in for f of x because that is like my y. And then we're going to go ahead and solve. So we have to think about our solving from the last chapter. First step would be to add 25 on both sides. And then because I have the quantity x minus 7 squared, I want to go ahead and take a square root. So the square and the root are going to make an absolute value. And then the square root of 25 is 5. So that absolute value is what tells me now I've got to write my two equations, because I could square a -5 or a +5 and get 25. So if I just had square root of 25 by itself, it's 5. But when I have a square and a root, like I've got here with that variable, that's what makes it different. So we have positive and negative. So 5 equals x minus 7. -5 equals x minus 7. And then we want to solve. So my answers are 12 is equal to x, or 2 is equal to x. And we want to write those as ordered pairs. Remember, ordered pairs are x comma y. So if my x is 12, but I started out with a y of 0, it's 12, 0. And then over here we have 2, 0. So these are going to be our x-intercepts. And remember, sometimes we won't have any. So if I had started out by, like maybe there was a plus 25 instead, and I'd started out by subtracting 25 on both sides, I'd be taking the square root of a negative. I wouldn't have any x-intercepts. So we have to think about that. Second part of this is finding a y-intercept. So we're going to let x equal 0. So that means I want to find f of 0. So f of 0 is going to be the quantity 0 minus 7 squared minus 25. 0 minus 7 is a -7. -7 squared means -7 times -7. So 49 minus 25. And that's going to be 24. So my y-intercept had a, I'm spelling it wrong here. My y-intercept had a 0 for x and a 24 for y, so that's 0, 24. So main idea today is just that we have different methods that we can use for graphing parabolas. So this is kind of all about the best way to look at a quadratic equation and figure out how to graph it. So you're going to see different problem types on your homework. There's going to be some that are already factored like this, that you're going to want to jump in and just find your x-intercepts and go from there. You're going to find some that are in vertex form. where you can graph using the methods that we've already learned. So as always, if you need help, please make sure you ask.